Good morning, friends. In last period, we have studied the numericals based on the Newton's law of gravitation. Today, we are going to see the next part of the topic, that is the acceleration due to gravity. Friends, here we are going to derive the relation between the small g and the capital G. So, before starting this equation, we will study the notations with their constant value and the meaning. Friends, this equation is very important fro- from the topic gravitation. So, first we'll see the meaning of small g. Small g is known as acceleration due to gravity. This small g have the constant value of 9.8 meter per second square, and the value of acceleration due to gravity will remain same on the surface of the earth. Friends, second constant is a capital G. Capital G is known as a gravitational constant. This gravitational constant is denoted with the symbol capital G. It has the constant value 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So, friends, small g and the capital G have the different meanings and the different values of the constant. Friends, in this equation, we are going to derive the relation between the small g and capital G. So, small g is the acceleration due to gravity, and capital G is the gravitational constants. We are going to obtain the relation between the both the small g and the capital G. So the question is, derive an expression for acceleration due to gravity on the surface of the earth. Friends, I have given this answer in the format of the question answer so that it will be very easy for you to make the notes. Friends, the first point says the earth is an extended object and can be assumed to be the uniform sphere. If the mass of earth is capital M and that of any point object is small m, the distance of the object from the center of the earth is a small r, then the force of attraction between them is F is equals to g m upon r square. Friends, we will study this concept in the proper way. Suppose this is a capital M. Capital M is called as the mass of the earth. Now consider another particle having the mass small m, which will be placed at a distance r from the surface of the earth. Let capital R be the radius of the earth and h is the height of the object from the earth's surface. Now, as we know, according to the Newton's law of gravitation, the force of attraction between any two particles is directly proportional to the product of their masses, and it is inversely proportional to the square of distance between them. A small m and the capital M are the masses, and capital small r is the distance between them. So, if we combine this, then we can get this formula: F is equals to G m upon r square. So, this will indicate that capital M is the mass of the earth, small m is the mass of the particle, and small r is the distance of the particle from the center of the earth. If the point object is not acted upon by any other force, it will be accelerated towards the center of the earth under the action of the force. The acceleration can be calculated by using the Newton's second law, that is F is equals to ma. Friends, here they have compared the force according to the Newton's second law. So when we are saying about the Newton's law, then already you have studied the Newton's first law, second law and third law. Just I am going to recall you. Newton's first law. Newton's first law says that every body will continue its state of rest or uniform motion unless it is acted by an external unbalanced force. Newton's second law says that the rate of change of momentum is directly proportional to the applied force and take place in the direction of applied force. And the Newton's third law says that every action has equal and opposite reaction. Friends, in the given equation, the Newton's second law will be used. So F is equals to ma. Here, force is compared with in terms of the mass and the acceleration. So equation first says that F is equals to gmm upon r square. Equation 2 says that F is equals to ma. So we have to compare equation 1 and 2. So the comparison from the equation 1 and 2 says that the ma is equals to gmm upon r square. If you observe both the side, then what will happen? Small m will be get cancelled. And what finally we are getting? We are getting small a is equals to gm upon r square. This is small a is equals to gm upon r square. Now this small a will be replaced with the small g. Small a will be replaced with the small g. So we can get here g is equals to gm upon r square. So this is the relation between the small g and the capital G. So friends, here we can say that the g on the earth's surface is equals to gm upon small r square. Now, if the object is close to the earth's surface, then the small r will be replaced with the capital R. So on the earth's surface, we are getting g is equals to gm upon capital R square. Now, how does the capital R will come? So here we have got the relation at g is equals to suppose gm upon r square. Now what is small r? Small r is the radius of earth plus h, that is the height above the surface. Now if h is very small, h is approximately small, then we can consider it as a 0. Then what will happen? Small r will become a capital R. So we can write the g is equals to gm upon capital R square. So remember, this is the relation between the small g and capital G. So small g is equals to gm upon capital R square, where small g is the acceleration due to gravity, capital G is the gravitational constant, capital M is the mass of the earth, and capital R is the radius of the earth. So this is a total equation which will be given here. Friends, I am going to explain you some another concept here. So already we have got this relation g is equals to gm upon r square. So this will indicate that this is a capital M mass of the earth and small m mass will be on the earth's surface. Now if this mass is raised above the surface, we can write the use the symbol gh, means the acceleration due to gravity above the surface is equals to gm upon r plus h bracket square, right? So what is the g? G is acceleration due to gravity on the surface. So what is the formula? G is equals to gm upon r square. Now if this mass is raised above the height above the earth's surface at a height h, then we can write gh is equals to gm upon r plus h bracket square. So this is the relation between the small g and capital G. Lots of time it is observed that it will in some reference books gh is equals to gm upon r plus h bracket square when we are taking, then r plus small r is equals to r plus h is taken into consideration. So gh is equals to gm upon r small r square will be taken there. And what is the small r? Small r is equals to r plus h. And what is r? R is capital R. Capital R is the radius of the earth. And h is the height above the surface, and small r is the total distance. So that notation also you should be known before solving the numericals. So friends, here we have studied the important relation for the expression of the acceleration due to gravity. In short, I am going to explain this equation once again. Initially, what we have taken, we have considered the gravitational force. So according to the Newton's law of gravitation, the force of attraction between any two particles is F is equals to gmm upon r square. What is here? Capital M is the mass of the earth, small m is the mass of the particle, and small r is the distance between these two particles. Now if the object is if the point object is on the earth's surface, at that time the force acting on the particle is given by the Newton's second law, that is F is equals to ma. So in equation first, Newton's law of gravitation is there, and in equation second, the force is given according to Newton's second law. So we have to compare this force. So ma is equals to gmm upon r square. So mm will be get cancelled. So small a is equals to gm upon r square. Now this small a will be replaced with the g. So g is equals to gm upon r square. Here small r is equals to capital R plus h. As the object is very close to the surface, then h will be 0. So we can write the g on the surface is equals to gm upon capital R square. So this is the relation between the small g and the capital G, or we can say this is a relation for acceleration due to gravity. This question may be asked during the examination for 2 or 3 marks. Friends, now we are going to see the numericals based on this article. Okay, so what does the question says? The question says calculate the value of universal gravitational constant from the given data. Mass of the earth 6 into 10 raised to 24. So we can consider this mass of the earth as a capital M. Then the radius of earth is a 6400 kilometer. So we know that 1 kilometer is equals to 10 raised to 3 meter. So while solving this kilometer we have to convert in terms of the meter. So this is the radius of the earth, capital R, and the acceleration due to gravity on the surface is g is equals to 9.8 meter per second square. So based on the given data we have to solve the question. So first, capital M, that is a 6 into 10 raised to 24, capital R 6400 kilometer. Friend, here the kilometer will be converted in terms of meter by multiplying with the 10 raised to 3. At the same time we have shifted the decimal point up to the 3 digits, so we have got the value as a 6.4 into 10 raised to 6. Small g, acceleration due to gravity 9.8 meter per second square. Here we have to find out the capital G, the gravitational constant. So we know the mathematical formula, G is equals to gm upon r square. Friends, the gravitational constant have the value 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So before solving this question we should know that that is the standard value, and as all the standards value are given, so our final answer should be very close to that constant value. Now we'll move to the solution of this question. So once we know the formula, so small g is equals to gm upon r square. Then in terms of capital G, the formula is written, that is capital G is equals to gr square upon m. Now g, where small g is a acceleration due to gravity, its value is substituted here 9.8. Capital R, that is a 6.4 into 10 raised to 6 bracket square upon capital M, is the mass of the earth 6 into 10 raised to 24 kg. These values are taken here. Then after solving this bracket we will get the answer as in the numerator 401.4 into 10 raised to 12 divided by 6 into 10 raised to 24. So after doing the calculation we can get the final answer as a 6.69 into 10 raised to minus 11 Newton meter square per kilogram square. Hence we can write the answer, the value of gravitational constant is 6.69 into 10 raised to minus 11 Newton meter square per kilogram square. Friends, you should write the question, write down the given data, and do the calculation. You can do the calculation by simple multiplication, or you may use a log table for solving the solution of this question. Friends, now we'll move to the next question. So the next question is very important one, and this is asked in the different competitive examinations in the CET, JEE and the NEET examination. So this is also based on the relation small g is equals to gm upon r square. So this is the, what is the small g? Small g is the acceleration due to gravity. Normally, if we are writing the weight, so what is the formula of weight? So formula of weight is that w is equals to mg. So if we multiply by the acceleration due to gravity with the mass, then we'll get the weight. So that concept will be used here. Okay, now I'm going to read the question. A body weight 5.6 kilogram weight on the surface of earth. This is the weight. This is a not mass, this is a weight, right? How much will be its weight on the planet whose mass is 1 upon 7 the mass of the earth and the radius is twice as that of the earth? Okay, so here the weight of the body is given, so we can write the we, that is the weight of the body on the surface of the earth, that is a 5.6 kilogram weight. Now here the mass of the planet is 1 upon 7 the mass of the earth, so you may write that here mp, mass of the planet, is equals to 1 upon 7 multiplied by me, that is the mass of the earth. And if we take the ratio mp upon me, then we can write as a 1 upon 7. So as per the question, mp, mass of the planet, is equals to 1 by 7 as that of the mass of the earth. So we can write the mp upon me is equals to 1 upon 7. So here you will observe that mp upon me is equals to 1 upon 7 will be written here. Now what does the second condition say? That the radius is twice as that of the surface, as the radius is twice that of the earth's radius. So here also we have tried that the rp, radius of planet, is equals to half of radius of the earth, re. So rp upon re is equals to 1 upon 2. Radius of planet to the radius of earth is equals to half, means 1 upon 2, that is here. So that ratio we can write here. So you can observe that the rp upon re is equals to 2. So this is a totally given information. So weight on the earth's surface is a 5 by 6 kilogram weight. Ratios of the mass of planet to the mass of the earth is a 1 by 7, and the ratio of the radius of planet to the radius of the earth is a twice. So what you have to find? The weight of the body on the surface of planet. If this body is taken on the planet, what will be its weight? So this is the given information. Now we'll move to the solution of this question. Here weight on the earth's surface is 5.6 kilogram weight. Ratio mp upon me is equals to 1 upon 7. Rp upon re, planet to that of the earth, is a 2. Now what we have to find out? We have to find out the weight of the body on the surface of the planet. Now we know the formula that w weight is equals to m into g, that is a gmm upon r square. Now here we have to take out the ratio of the wp upon we. So here I am going to write that explanation. Weight on the planet is equals to g, acceleration due to gravity on the earth's surface, mp, mass of the planet to the mass of the body, divided by r square p. So this is a formula for the weight of planet. Similarly, weight of the earth is equals to g me, mass of the earth, small m, mass of the planet, to the r square e. Now we have to divide these two, 1 with the 2. So we upon wp upon we will be remains as it is. G will be get cancelled, small m will be get cancelled, and what we are getting, the ratio mp upon me divided by this r square e will be goes to the numerator, r square e upon r square p, right? So friends, this step is not given there, directly the next step is here. So this step you can note down in your notebook. Wp, that is the weight of the planet, is equal to gmp upon m upon r square p. Similarly, we, weight on the earth surface, is equal to g me, mass of the earth, multiplied by small m upon r square e. So this we have to take out. Then 1 divided by 2. After dividing, what we are getting? This step we are getting wp upon we is equals to mp upon me multiplied by r square e upon r square p. Right, friends, here we, that is the weight on the earth surface, is a 5.6 kilogram weight. mp upon me, the ratio is 1 upon 7, and re, here you will observe that the rp upon re is a 2 upon 1. So we want the reverse, means re upon rp, it will becomes 1 upon 2. So 1 upon 2 square. So here they have given the answer directly. If you I am going to explain how does that answer comes. Here wp upon 5.6 is equals to 1 upon 7 multiply by, if we take the square of 2, that will becomes a 4. So wp is equals to 5.6 is equals to 1 upon 28. Right, now this 56 will be goes there, then it will becomes wp is equals to 1 upon 28 multiply by 5.6, and 28 ones are 28, 28 twos are 56, and after 1 point there should be the decimal, so it means a 0.2 kilogram weight. Friends, in this question you should obtain the ratio properly, and once you will get these ratios properly, then you should know the formula of the weight, that is a w is equal to mg, that is a gmm upon r square, and then we have to take out the ratio so that we can get the final answer. So our final answer is a 0.2 kilogram weight. Again I am going to explain this question in the proper manner. The question says that the body weight 5.6 kilogram weight on the surface of the earth. How much will be its weight on the planet whose mass is 1 upon 7 as that of the mass of the earth? So mass of planet to the mass of the earth ratio is 1 upon 7, and the radius is twice as that of the earth, means the radius of planet is equals to twice as that of the earth. So rp upon re is equals to 2. And what you have to find out, we have to find out the weight of the body on the planet. So what is the formula for the weight? Weight is equals to mg is equals to gmm upon r square. Now here we have to write the weight of the planet. wp is equals to g mp upon small m upon r square, and weight of the earth we is equals to g me upon small m upon r square e, radius of the earth. Then this is the radius of planet and this is the radius of earth. Then we should divide 1 with the 2. If we divide these two equations, then we are getting this equation, wp upon we is equal to mp upon me multiplied by r square e upon r square p. Once we get this equation, then substitute the values. mp upon me 1 upon 7, rp upon re 1 upon 2, and if we solve this, then finally we'll get the answer as a 0.2 kilogram weight. So the weight of the body on the surface of planet will be the 0.2 kilogram weight. So friends, here we have completed this numerical. So today we have studied the important relation between small g and capital D, that is a g is equals to gm upon r square, and based on that we have studied the solved the numericals, as well as we have also studied the second formula of the weight is equals to mg. So based on that also we have solved a one important question. So friends, note down the mathematical formulas and note down the equation, and you can write the question and answer for the numericals. I hope you have understood these numericals. Thank you. Have a nice day.